Okay, so we're talking about calculating theoretical yields here. Now, it's called theoretical because if you put the numbers in and do the sums, these are the figures you'll get. But if you actually do the experiment, then it's not the case. And we'll go into a little bit more about that later on. But let's have a look at a couple of problems. If you haven't watched the two videos previously on atoms and relative formula mass, you'll have to, because that will help you out a lot. Okay, first one. Calculate the mass of magnesium oxide produced if 10 grams of magnesium is burnt in air. So, first thing we've got to do is write out the actual equation. So here's the word equation. Magnesium plus oxygen goes to magnesium oxide. We've got the symbol equation here. Now, if you look, it's not balanced. Now, don't worry. If you want to know about balancing equations, you can. There's a good Khan Academy video, and there's a link to that from my website. I might do a video soon on balancing equations, but these are pretty simple. You can see that we've got two oxygen atoms there in that molecule, O2. So we're going to have to balance that up. Now, on the other side, you can't just add a small 2 to the magnesium oxide. You can't mess with the little numbers. So all we can do is put a large 2 in front of the whole thing. Now that sorts our oxygen problem out. That gives us 2 oxygens, but it's also given us 2 magnesiums. So we're going to have to go to the other side and put a 2 in front of that one as well. Now, that's the first stage. We've got our word equation, we've got our balanced symbol equation. The next thing we're going to have to do is we're going to work out the relative formula masses of these things. Now, the question said calculate the mass of magnesium oxide if 10 grams of magnesium is burnt. It doesn't ask for the oxygen, so don't worry about it. Don't waste your time working out the relative formula mass of oxygen here. We're only interested in the magnesium and the magnesium oxide. So, if you've watched the videos previously, you'll know that magnesium has a mass of 24 and oxygen has a mass of 16. So you should be able to work out those relative formula masses quite easily. So what this tells me is 48 parts or 48 bits of magnesium will give me 80 bits of magnesium oxide. It doesn't matter what it is, it's a ratio. So 48 grams of magnesium will give me 80 grams of magnesium oxide. 48 tons of magnesium will give me 80 tons of magnesium oxide. It doesn't matter, it's just a ratio. So you shouldn't have any trouble getting to that stage. Now, let's ask the question, what would 1 gram of magnesium give me? So the way I do that is I divide it by itself, and that will give me 1 gram. So what you do to one side, you must do to the other, just like in maths. I've divided the magnesium by 48, so you have to divide the magnesium oxide by 48 as well. And what this tells me is that 1 gram of magnesium will give me 80 divided by 48 grams of magnesium oxide. So 1 gram of magnesium will give me 1.7 grams of magnesium oxide. Now the question didn't ask me what 1 gram would give me, it asked me what 10 grams would give me. So I multiply the answer by 10, and that gives me 17 grams. Okay, in case I went a little bit quick there, let's do another example. This time I'm going to approach it from the other way. I'm going to say not how much reactant do I need or how much product would I get, but this time how much reactant do I need. So this time I want 2 kilograms of hydrochloric acid, and I need to know how much chlorine is going to be needed. You can imagine that sort of question is going to be quite common in industry, that sort of thing. How much reactant do I need to produce this much product? So again, there's my word equation. We're just going through the same steps again. Now we need our symbol equation. Can you see whether it's balanced or not? It's not. You've got 2 hydrogen atoms there, and you've only got 1 on the other side. This is just like the magnesium one. We need to put a 2 in front of those, the chlorine and the hydrochloric acid, and now we're balanced. Okay, next step, step 2, just like before. What's the relative formula mass of these things? Well, hydrogen has a mass of 1, chlorine has a mass of 35.45. There's our relative formula masses. I've rounded chlorine down to 35 there. The question will state whether you do that or not. in your exam paper it will state whether you round it down or you keep it as 35.4 or 35.5. In this case I've rounded it down to 35, and that gives me relative formula mass of 70 and 72. So what does this tell me? This tells me that if I wanted 72 kilograms of hydrochloric acid, I'd have to use 70 kilograms of chlorine. Now from that we can work out, what if we only wanted 1 kilogram of hydrochloric acid? Well, we divide it by itself to make that into a 1, and like in maths, what you do to one side, like in the equations, what you do to one side you must do to the other side. So we divide that by 72, and what this tells me is 1 kilogram of hydrochloric acid comes from 0.97 kilograms of chlorine. Now the question didn't say 1 kilogram, it said if I wanted to produce 2 kilograms. So if 1 kilogram comes from 0.97 of chlorine, then to get 2 you just have to multiply 0.97 by 2, and that gives us 1.94 kilograms of chlorine. Bit quicker that one, a little bit more complicated. Rewind, watch again if you need to. But here's some questions. Have a go. Pause the video now and unpause when you've got some answers, and if they don't match up, have another crack, go back, watch it again. If they do match up, well done. Okay, there's your answers. Well done.